The term stress can mean so many things. It should help then to talk about a few terms related to stress. When we initially face a situation or an event, we evaluate it. Based on this evaluation, we may perceive this event as a threat or not. And also, we evaluate our abilities for dealing with this event. Psychologist Richard Lazarus sees that our initial perception of the event is more important in determining its impact than the event itself. So, if this event is perceived as threatening and exceeding our ability to cope, then we think of it as a stressor. This stressor then triggers a full-blown stress response. You can think of many types of events, and one of these is related to having a significant personal life event, like divorce or death of loved ones or job loss or even moving to a new environment and so forth. Another category is experiencing a major traumatic event, like being victimized by an act of violence, being in a war zone, living through a natural disaster like tornadoes. Then there are the daily hassles, daily irritants, for example, interpersonal conflicts, misplacing or losing something important to you, concerns about health, concerns about safety, microaggression, and so forth. These daily hassles, because of their frequency, they tend to be highly taxing in terms of the ongoing cost to our well-being. So you encounter an event, perceive it as threatening, and you think you may not be able to deal with it effectively. What happened next? A stress response is triggered. The concept of the stress response is related to a term called homeostasis, introduced in early 1900s by an American physiologist, Walter Cannon, who describes homeostasis as the way the body tries to maintain stability and internal balance in the face of any change, like changes in the body temperature, for example. In his research, Cannon observed ways animals responded to external threat and danger. And he came up with the term fight or flight response to describe what happens in the body in response to threat and when trying to restore homeostasis. Multiple systems in the body, including the nervous system and the endocrine system, work to help with orchestrating a fight or flight response or a stress response. For the central nervous system, we have the brain with many internal structures that contribute to the fight or flight stress response. The brain has extensive communication network throughout the body. This corridor here within the spinal cord with nerves that are distributed to other parts of the body. We also have the autonomic nervous system, which acts automatically and reflexively to try to maintain the homeostasis as indicated by Walter Cannon. There are two branches of the autonomic nervous system that work in opposite direction in a way. One is the sympathetic nervous system, which is the part of the nervous system that is going to activate the body to take on the challenge or deal with the threat, to fight it or escape from it in order to avoid harm. The other branch is the parasympathetic nervous system, which works more to establish start of resting or restoration. But back here to the sympathetic nervous system, we see the activation of all these organs. For example, here you would see the heart increasing its beats, increasing the force of its contraction with every beat, all to supply as much blood to the body as possible to carry oxygen and nutrients to help the body meet the intense demands at the time of stress. Also related to our cardiovascular system, our peripheral vascular system constrict as a way to push more blood to important areas of the body, like our brain, to help us prepare and make decisions in the moment and execute those decisions. We also see increase in respiration rate and dilation of the lungs so that they can work fast and efficiently. That way, we can have more air, more oxygen to the blood, and then to all body tissues. The breathing also helps expel the carbon dioxide that our muscles will need to clear out during this intense period of time. During this time, certain functions are turned down or even turned off completely. Examples of functions that get turned off are digestion, immune functions, and ovulation. In addition to the sympathetic system, which is very quick and efficient to turn on, the endocrine system is also activated in response to stress, but it is slower in its reaction. The endocrine system includes multiple glands distributed throughout the body. These glands release chemicals we call hormones that convey messages throughout the body. Some of these hormones are released to activate various tissues of the body to help with the stress response. Two glands sit on the top of the two kidneys, and they are called the adrenal gland. Each has two parts. One is the adrenal medulla, is the inside part of the adrenal gland. This part releases catecholamine, epinephrine, and norepinephrine, sometimes called adrenaline and noradrenaline. Epinephrine is the one that is more functionally important here. It helps in communicating to other parts of the body, like the heart to increase heart rate and to the vessels to increase blood pressure. These are functions that support the sympathetic nervous system response to the threat or the stressor. In the other outside layer of the adrenal gland is another part called the adrenal cortex. From here comes a stress hormone called cortisol. So cortisol is so important to many functions in the body since it affects just about all tissues, including the brain. Cortisol release is not directly linked to the sympathetic nervous system, although they work together. Cortisol is part of another stress response system called the hypothalamic pituitary adrenocortical axis. This axis includes three structures: the hypothalamus, the pituitary gland, and the adrenal gland. The hypothalamus is a structure located in the brain that releases a hormone called corticotropin releasing hormone, CRH. CRH is transported to the pituitary gland, also in the brain, and there it stimulates the pituitary to synthesize and release a hormone called adrenocorticotropic hormone, ACTH. ACTH moves through the blood circulation and reaches the adrenal gland, particularly the cortical part of that gland, causes it to synthesize and release cortisol. As mentioned, cortisol is an important stress hormone. It affects major systems of the body and contributes to the system response in times of stress. And that is by distributing glucose, making more of glucose available, as well as acting as an immune suppressant, an action that is needed during stress since the body is in a fight or flight mode. In addition, cortisol provides feedback to the brain to slow down the release of ACTH and cortisol. We call this negative feedback loop. This is important to keep things from going out of control. So, in summary, the fight or flight response is considered the classic stress response, with the goal to maintain the body's integrity and balance through the process of homeostasis. The sympathetic nervous system helps us in this response, and endocrine hormones assist in this effort. There is also a relatively more recent evolution of the concept of homeostasis, and that is a process called allostasis introduced by neuroendocrinologist Bruce McEwen. This concept reflects the active process of maintaining homeostasis and the cost of this process on the body. This is an important term to consider when thinking about the effect of stress on health. Of course, in humans, the stress response incorporates powerful emotional and cognitive factors that shape and contributes to this allostatic response and its long-term effects on health and disease. Next time, we talk about how and when stress and related allostatic load can increase risk for disease in multiple systems.